These are sample calculations for experiment 6, a titration of an unknown weak acid by a strong base, NaOH. So prior to this point, we've generated a table of pH versus volume of NaOH added values and created this plot. This was done using Excel. Some points you want to note is that make sure you have a title, that each of your axes are labeled, and that it's clear what the units are on each of these axes, and that you have your values here labeled on each side. Now the first thing we want to do is to determine the volume needed to equivalence, and that's determined by the portion of the curve that has the steepest slope, which is this portion here, and halfway up this portion of the curve is where the equivalence point is found. Okay, so we go halfway up this slope, and if we measure it, we find it's going to be right about here. So if we draw a flat line over okay, so this is going to be the pH at equivalence. Now your graph might not look quite as nice as this. This is set up so that we see that they're at 40 milliliters. Here we are at the equivalence point, and this is the volume of NaOH to equivalence. And we know this is going to be 40.00 milliliters. It just happens to be that on this example. We need to know this value because we need to know the volume to half equivalence, 1/4, and to 3/4 equivalence. So 20 milliliters here is 1/2 of 40. So this is the volume to 1/2 equivalence. And if we draw our line over to the pH, we try and be as flat as possible. Okay, we see that the pH at 1/2 equivalence, and here we have to estimate. I'd say it's probably about 4.88. We do the same thing for volume at 3/4 equivalence. So we have 40 divided by 40 times 0.75 for 3/4 equivalence. So that's 30 milliliters to the 3/4 point. And at 30 milliliters, the 3/4 point, that's going to be, let's see, about, okay, there, draw a flat line over, and this would be the pH at 3/4 equivalence. And as I estimate it, it's about 5.38. And now for quarter equivalence, that's going to be at 10 milliliters. So 40 divided by 4, 10 milliliters. That gets us to pH at 1/4 equivalence. And let's see, 1/4 equivalence, about 5. And you're going to have to do your best in terms of interpolating here. pH at 1/4. say it's approximately looks to be about 4.56. Okay, obviously we are estimating here. Alright, so we have our lines. Okay, this is 3/4 point, volume to the 3/4 point, and this is volumes to the 1/4 point. Okay, there is a labeled graph in your lab manual that also shows this in terms of all the points that you need to show for full credit on your laboratory. Okay, so as far as calculations now, we have the plot shown. So the volume to equivalence point we determined was 40.0 milliliters, 00 milliliters. So remember, we always have 2 decimal places in every burette reading. So the volume to 1/4 equivalence is 1/4 times 40, 10 milliliters in this example, and for this example, volume to 3/4 equivalence is 3/4 of 40.00 milliliters. And that would be 30 milliliters in this example. Alright, so we can get a pKa value from each of these. In a separate document, you see we've justified that the pH at the half equivalence point is equal to pKa, which in our example we found that was equal to 4.88. Okay, so we can find Ka is going to equal 10 to the minus pKa at this point. And so that's 10 to the minus 4.88. And we get a value for the Ka at this point equal to 1.32 times 10 to the minus 5. And we would report that on our data report sheet. Okay, so the pH at the 1/4 equivalence point, and that's going to equal our pKa plus, or at 1 equivalence point, what's true at that point, at 1/4 equivalence, is that the pKa is equal to the pH at the 1/4 equivalence point plus 0.48. So we found that the pH was 4.56. We add 0.48, and that would equal 5.04. So that's equal to our pKa. So we'd find our Ka is equal to 10 to the minus pKa is 10 to the minus 5.04. And that would be equal to 9.12 times 10 to the minus 6. Okay, now these differ by a small amount, but these values are based on analysis of accumulated data, so we wouldn't expect that they would be exactly the same, but they are fairly close. And finally, the pH at the 3/4 equivalence point, okay, we found to be equal to 5.38, and we know at this point, at the 3/4 equivalence point, that the pKa is equal to the pH minus 0.48. So that's 5.38 minus 0.48, and that is going to be equal to 4.90. So that's the pKa that we found according to the 3/4 equivalence point. So we'd find Ka here is equal to 10 to the minus pKa. Is 10 to the minus 4.90, and that would equal 1.26 times 10 to the minus 5. Again, fairly close to our other values, but not necessarily identical. Okay, so what we would do is report all of these values on our DRS and include with our DRS, okay, our graph that's close to a full page and labeled with all of the pertinent points.